Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to see about the case study on IoT-enabled smart appliances. So the Internet of Things is best suitable for reducing the cost and improving the efficiency, improving the quality and achieving a data-oriented predictive maintenance services. So these things enables us a smarter way to control the appliances with a low cost. So collecting a wide range of real-time data from products and then environment require smart sensors, reliable communication and seamless integrations. So getting the information, we use the sensors and then communication protocols to transfer that information to the system and cloud, and then seamless integration. So this will be required to integrate these devices. In IoT, a critical emerging smart home appliances for a higher customer satisfaction, for a higher energy efficiency, and then best personalization as per the customer requirement, and advanced big data analytics will be possible. Look at this diagram, IoT-enabled portfolio. Look at this. So this is a home appliances, smart home appliances like a refrigerator that will be controlled by devices, and smart homes, smart buildings, smart cities. So these IoTs can be sufficient for doing all the tasks because it have the sensors to sense the real-time data. So based on the real-time environment, so it can take the decision and control the appliances. So look at this. This is the tradition of conventional home appliance towards the portfolio of system up to into the smart cities. IoT has a higher potential of real-time data collection, providing a meaningful information, predictive maintenance at a low cost, while opening up a new frontier for a data-driven approaches for generating extra values. So the significant benefits are obtained from smart devices. Factors are willing to take a digital transformation by adopting IoT for these three main reasons. That includes energy efficiency, personalization, and advanced predictive maintenance. So the energy efficient, so we can get an low power consumptions because we can efficiently turn on or turn off the devices based on the real-time environment. No manual power will be involved in it. So automatically we get a effective system. Again, the power consumption of the system is very low. So if you go for a PLC or any other devices, the power consumption of the device is very high. But if you go for this IoT, we use only microcontrollers. So the power consumption is in terms of only milliwatts, or even it should be in a nanowatts. So even if you work for a 24/7, but still the power consumption is in terms of only less than few watts only. So that's the main reason for this energy efficiency of IoT devices, because there is no devices it consume a higher power. So we use only sensors and embedded for microcontrollers. All these things are consume a very less power. So it will be operated with a 5 volt, or even it will be operated with a 3.3 voltage DC. So automatically the power consumption is ultimately very low. Second one, the personalization. So whatever the customer need, so we can personalize that product for their requirements. So the personalization will be very easy, and that will be satisfy the customer needs. So if we go with, look at this, if you have a system with an PLC or any other devices, so to increase the relays or anything, so entire system complexity will be comes. But if you go with an embedded IoT systems, so it will be very easy. We can integrate more number of IoT devices with easily, because we have a sufficient number of devices and protocols to support that. And then advanced predictive maintenance. So if we take a maintenance, we have two types of maintenance. One is a predictive maintenance, and another is that is actual after things so happens. So this will be have a predictive maintenance, means before appearing that fault, that will be maintained. So the advanced predictive maintenance can be done by using this IoT-enabled things. So if we go with this breakdown maintenance, what happens once the system breakdown? So the production will be stopped here. But if you go with the predictive maintenance schedules, so automatically the entire system will not be stopped at any time. So that before appearing any fault, that will be preventively identified, and then the maintenance will be carried out. So that is the main reason for choosing this IoT smart appliances. Look at this. So the concepts of IoT-enabled smart products. Look at this. This is the smart appliances. We take some of the examples. Even we have so many things we are using a day-to-day life. Washing machines, again microwave ovens, and then other some small things, fridge and what is that? Systems and all the things we can take. So all the household devices can be making as an smart appliances. So we are using the product. Only thing we need to connect some sensors and then activators. So sensors for sensing the data and activators for the controlling the appliances. So these things make the device as a smart appliances. So these smart appliances will be connected to the wireless protocols. So why we use a wireless protocol means we cannot connect each one with a wire. So the best preference will be a wireless protocols. The customer expects only wireless protocol to communicate the devices. Just if you imagine, you look at that, if you have an using a microwave oven or a washing machine, if it will be connected control signals, so it will make them very difficult. So that's why they prefer to use the wireless protocols. We have a n number of wireless protocols. Look at this: Wi-Fi, Zigbee, again 5G, LoRa, Sigfox, NB, IoT, Bluetooth. So these are some of the things it uses the wireless protocol. Still we have so many protocols. So depending upon the applications, the distance covered and then amount of things, signals to be transferred, we can choose any suitable wireless protocols. And then this is the IoT middleware. So here we have the REST APIs, so WebSockets and other things. So here this actual things, the signals will be transferred to the device, and that will be WebSocket, that will be transfer the devices is the cloud. So each devices we control, use this microcontroller also. So these act as a single node. So all this node informations will be collected through this wireless protocol, and that will be combined in this API WebSockets, and that will be given to the cloud. So cloud also we have so many cloud options. Public data, again sensor data, structured, unstructured data. So we can use suitable clouds for that application. So we have so many free cloud platforms, and we can have higher configurations and applications. We can go with the paid versions also. The concepts of IoT-enabled smart products system framework consists of main 4 parts: smart appliances, wireless protocols, IoT middleware, and cloud. So what we see in the previous slide. So where smart home appliances are connected to the cloud by using the wireless protocols and IoT middlewares. So this framework is suitable for all home appliances by using a smartphones as a gateway to access wireless capability, internal memories, and process for using the cloud-based resources. Making an ordinary home appliances smarter requires a structured and expandable solution, and customization needs to take place in the 3 parts: appliances, industries, and technologies. Look at this example: end-to-end IoT-enabled home appliances system. Look at this. This is the refrigerator, and look at this. This is the main board, and this is the node board. It's an IoT board, and then this is we use this serial communication. So whatever the sensors that will be connected by using serial communication, or we can use any serial communication. I2C we can use, or CAN protocols we can use. So this will be, we can taken a wired communication up to this board. See, within this IoT and these sensors and then activators will be connected by using wired. So we can prefer to use the serial communication. And then from this IoT board to middleware, we use the wireless communication like a Wi-Fi or an what is that? This is an Bluetooth, or we can use an LoRa, or we can use an other NFC protocols to communicate this node to the middleware forms. But within that things, because if you take in the refrigerator, we have the cloud, all the information. So there we can use a serial communication. Serial communication requires only 2 wires. So this will be considered as a single node. So this is the smart refrigerator. Even we have so many things. So we can take a microwave oven, or we can even take a doorbells, all the things. So each things we use some sensors and then activators, and then we use on cloud microcontrollers, or we can say it is an Arduino board or an Raspberry Pi boards. So these will be connected through wireless protocol and then through the middleware platform. Look at this. Here we have the real-time monitoring and controlling systems. So look at this. So we use this UBI dots cloud platform. So these information will be stored in the cloud. Wherever we require, we can take the data. So look at this, the real-time data can be monitored from a mobile phone or a PCs. Similarly, the historical data also can be viewed from a mobile phones or a laptops. So wherever we have an internet facility, we can access that information. Even we can take some graphical representation of the signals also. We can plot the values. We can fix some threshold also. For example, if you take this refrigerator, we are setting the temperature as at 20 degree. So whenever if the temperature decreases below 20 degree, we automatically turn off the devices by using the activators. Look at this, temperature, cooling levels, activators, fridge cycles. So all the things. So still we can use so many things also. Each places we can use some different sensors to measure the temperature, humidity and all the things. So based on that we can turn on or turn off that particular things, or we increase the temperature or decrease the temperature automatically. Even we can monitor whether that what is the temperature present in this, whether we can automatically or manually also we can control the temperatures, and we can change that also. That means, for example, if you set the temperature, whenever if it goes below 20 degree, we can turn off. If it goes above 22 degree, we can turn on. So whenever if you feel that it to be changed, the user can easily change by using his mobile device or a laptop. No need to wait for a program or a system appliance persons. So very simply, the user can modify all the data, whether to be turn on or turn off. For example, if the refrigerator is not used for 2 days, so simply the user can turn off the devices from the cloud with easily. So that's why that personalization will be very high in these devices. The system consists of 3 main divisions: smart product, communication protocols, and real-time monitoring and control also. So we can monitor the parameters, also we can control the parameters. First, refrigerator need to upgrade to become a digital assist. So rather than just a physical product, so just we need to integrate that sensors. So that's the upgradation is needed. Second, proper wireless communication is required to building the system. So what means, so once the system is connected, it collects all information that will be available in that refrigerator itself, but it should not go with the cloud. So that we need some communication protocols. And lastly, an IoT framework and visualization of and cloud capability is essential. So IoT framework, so that the access the cloud data and then that visualize it, take a graphical representation and gives to the user easily understandable. Thank you.